Have you ever wondered how the software you use every single day seems to get better and better, or sometimes worse? Well, it's not luck, and it's definitely not magic. It's engineering. Today, we're going to pull back the curtain on the powerful feedback loop that turns software quality from a hopeful guess into a hard science.
Now, everything we're diving into today is grounded in a software quality engineering lecture by Assistant Professor Abdul-Rahman Mahmood. He's not only an IT and cybersecurity consultant, but also the author of the Alpha Pillar crypto tool. And get this, that tool is officially used in certified ethical hacking labs and is even distributed with Dr. William Stalling's famous textbook on cryptography and network security. So yeah, we're drawing from some serious expertise here.
Okay, let's start with a feeling we've all had. You see that little notification, update available. You tap it, and you kind of hold your breath, right? Is this update going to be amazing with all the new features you wanted, or is it going to be a complete, buggy disaster? The real question is, how did the creators decide it was ready for you? How did they know?
Well, the answer to that question is a really powerful concept called the quantifiable quality loop. This is the secret sauce, the system that takes building software out of the world of just, guesswork and hunches and puts it firmly into the realm of science and engineering.
So, what on earth is it? Put simply, quantifiable quality improvement is all about turning that vague feeling of quality into cold, hard numbers. It's a whole process of using actual measurements and data models to see how the software is really doing compared to the goals they set. This lets teams analyze and improve their work systematically, not just based on a gut feeling.
And at its core, this whole thing is a loop, a cycle that never stops. It's got 3 key stages. First, you monitor and measure. You collect data on everything. Next, you analyze it. You turn that giant pile of raw data into insights that you can actually use. And finally, you get to feedback and follow-up, where you take those insights and make smart changes. And then, the loop starts all over again.
All right, so let's dig into that first step, measurement. To really get a handle on quality, you've got to be collecting the right information. And that information really comes in 2 main flavors. You've got your direct clues and your indirect clues.
Direct measurements are exactly what they sound like. The obvious stuff you can see and count that screams quality or lack of quality. The number one example is just counting the number of bugs. But indirect measurements are where it gets really clever. These are the indicators you use early on, way before the product is finished. They help teams predict and control quality before a single user ever gets their hands on it.
So what are these indirect clues? Well, engineers look at pretty much everything. They look at the environment. How skilled is the team? How much experience do they have? They dive deep into the product's internals, measuring things like how complex the code is. And they track activity, like how long does a development cycle take? It's this 360-degree view that helps them spot trouble long before it starts.
Okay, so collecting all this data is great, but it's pretty useless on its own, right? That brings us to step 2, the analysis engine. This is where those raw numbers get transformed into actual project-guiding decisions.
Think of analysis as the bridge. It's what connects the dots between all the stuff you measured and what you're actually supposed to do about it. Without this step, you're basically just collecting data for fun. It's the analysis that gives it meaning.
And here's how critical this becomes in the real world. A team has to decide, is the product ready to release? Well, they're not just guessing. They're looking at reliability models and defect data. Is it time to move to the next stage of development? They check the code inspection results. Do we need to move more people onto this feature? They look at the defect trends. You see, every big decision is backed by data.
And that leads us to the final and honestly the most important step, closing the loop. Because all that measuring and analyzing doesn't mean a thing if you don't actually act on it. This is where feedback becomes action. But here's the thing. Feedback isn't just one thing. It operates on different schedules. Sometimes you need immediate feedback, like this critical thing is broken, fix it now. Other times it's short-term, guiding the current phase of the project. It can be a huge project-level decision or even long-term, changing how the company builds software for years to come. So, what does this look like in the trenches? Well, immediate feedback could be as simple as retesting a bug that was just fixed. Short-term might be reassigning a developer to a tricky part of the code. Project-level feedback, that's the big one, the final go or no-go call on the release. And long-term is taking all those lessons learned and building better ways to prevent bugs in the first place. It's about constant improvement at every single level. Now, as you can probably imagine, this isn't all happening on a spreadsheet or a whiteboard.
This entire feedback loop is powered by a whole ecosystem of sophisticated software tools, all designed to make quality predictable.
This tool ecosystem really breaks down into three main parts. First, you've got your data gathering tools, things like defect trackers and code scanners that pull in all the raw info. Then you have the brains of the operation, the analysis and modeling tools that crunch all the numbers. And finally, you have presentation tools, all those dashboards and graphs that make the data easy to understand so the team can actually make a quick decision.
So, if we boil this all down, we get to this key idea from Professor Mahmood's work. By using this feedback loop, quality stops being this mysterious, unpredictable thing. It becomes a quantified entity, something you can actually assess, predict, and control, just like any other part of engineering.
And that really leaves us with one last thing to think about. Quality isn't a destination. It's not a finish line you cross. It's a continuous loop. So the next time your favorite app updates, take a second and think about it. What kind of invisible feedback loops are running in the background right now, working to make that product just a little bit better for you tomorrow?